Okay, back at it, another week of me sitting on my ass to teach you guys. Okay. Where were we? It's hard to even wrap my head around where we are on any given day. Okay. Oh, I remember. Last week where we left off was we looked at our first look at what a normal distribution looks like. And we specifically built this bell-shaped curve, and we got the idea that a normal distribution is some x variable. We say it kind of belongs to the normal distribution where there's a mean, that's the first number, and a standard deviation squared. Okay, that's what we're looking at. Hey, babe. What do you want to show? Can you come? That's okay. That's close. Morgan's doing like, it's kind of like paint by number, but it's sticker by number. So she has to find all these stickers. There's 54 of them, Morgan. What number are you on? 12. 12 of 54. So she's going to make this. Can we tell what it's going to be? A parrot. Do I show them what happened to you? This is a different class. This one has Gracie and Megan in it. We can show them. Show them. Tell them what you did. Say it out loud. You want me to say it? She lost her first tooth last night. Yay! She was waiting a long time now. She feels like a big kid now. She lost teeth. Okay, go finish this and let me can teach. Okay. So we said if some random variable x belongs to a normal distribution, the number that comes first is always going to be your mean. And other number, if it has a squared here, you just take that's really the variance. But the standard deviation is just the number that's in. If it's already been squared, you have to take the square root. If it's in squared form like this, you just take the number. Okay, so this is sort of the question and why this sort of comes about, what we're going to be going into now. 4.3 is going to take us into what we call the standard normal distribution, because last week every normal distribution we looked at fit within the 68, 95, 99.7% rule. Well, this one's not going to, there's such situations where it doesn't fit into that rule perfectly, so in order to come up with percentages, we have to have something to compare it to. So this is kind of like a classic example where you say there's two classes going on, class 1, class 2, maybe two different teachers, two different schools, whatever it happens to be. And you and your friend both have 80%. And they say, well, your school is easier than my school, your class is easier than my class, so is 80% really worth 80%? No. That's sort of the scenario we're looking at. So then you can start making a valid point. Is 80% in one class the same as 80% in another class? If it's the same class, should all marks be equal? Well, probably not. There's all kinds of variables, right? Maybe the size of the class, maybe different teaching styles, maybe the time of day. There's all kinds of variables that may change what value your mark has. So if we look at these two classes, class 1, if you take a look at this, it's a normal distribution with a mean of 75 and a standard deviation of 3. So if I was going to put that onto this graph, remember the mean goes in the middle, 75. That's the average. The class average is 75%. A standard deviation of 3 means that if I go 3 above, that gets me to 78. 3 below, that gets me to 72. That's one standard deviation away. Remember from last week, 68% of all people in the class would have a mark between 72 and 78. That's pretty consistent. Now, remember, we always put the mean in the middle, and then we draw 3 standard deviations above and 3 standard deviations below. So I'm going to continue to add 3 and subtract 3 2 more times. So 78 plus 3 is 81, plus 3 is 84. If I subtract, I get 69 and 66. So basically what this distribution is telling me, based on the 68, 95, 99.7% rule, is that 99.7% of kids have a mark between 66 and 84. That's pretty good. To some of you are going, 84? No one's got a mark above 84? Well, maybe 0.15% of people do. But this teacher is tough but fair, right? This class is tough but fair. Everyone can get a decent mark. No one can get really a great mark. And no one does that poorly. Okay? If I take a look at the next section, which I'm calling class 2, they have a class average of 79. Okay, similar. It's a little bit higher. This one had a class average of 75. But their standard deviation is 7. That means that's a measure of spread, remember? That's how far away from the mean you are. That means people are all over the place in marks. See what happens when we add 7 3 times? We get 86. We get 86. 93, and we get 100. Ooh. And if we subtract 7, we get 72, 65, and 58. So in this case, we're saying 99.7% of people have marks between 58 and 100. Oh, great. Lots of people have high marks here. Yeah, it also adds to the idea that lots of people have lower marks as well. Okay, so it's actually reducing at a quick rate as well. So not only are there people on the high end, there's also more people on the low end. Less people in the middle. Okay? Being this little middle, 68% are within 6% of each other. Here, 68% are within 14% of each other. So they're definitely different things. And how do we compare this? We say you have a mark of 80%. Where would 80% lie on here? So let's draw a line. 80% here is obviously close to 81. So if I imagine right here, this is my mark in purple right here. Your friends in the other class, they have 80%. Well, where does 80% lie here? Right beside 79. Well, these are nowhere near the same spot on the curve, right? This is almost the average. If you have 80% in this class, you're right around the average. If you have 80% in this class, you have a great mark. So is 80% a better mark in this class or a better mark in this class? That's sort of the classic question. And people would argue that because the majority of the class, the greater percentage, if you look at the area under this curve, is on the left side, the majority of the class is doing worse than you. Only these few people up here are doing better than you. That means you have one of the highest marks in the class. That means you must have a good mark. If you look over here, just over 50% of the class has a worse mark than you. That means just under 50% of the class has a better mark than you. You're in the middle. So would you rather be the top of a tough class or the middle of a class that has ranging marks? Okay, so it's sort of a classic example. And I don't know, maybe you can't really answer it, what's the better mark? But what you can do is make a direct comparison of these two things by fitting them to something called a standard normal distribution. So a standard normal distribution is one that we've now, just to clarify things, we use Z as the variable that represents this. So we're taking our distribution, which is an X distribution, and trying to fit it on a Z distribution. A very specific Z distribution. It's one that has an average of 0, so we put that there, and a standard deviation of 1. So we add 1 3 times, and then we subtract 1 3 times. Okay? So we're saying if I can fit this curve onto this one, and this one onto this one, then I can make the comparison directly from this one. Okay, so that's the whole idea. This is called a standard normal distribution, and we end up converting X values to Z values using a very specific formula. Okay, so the formula is this. You take your X value, in this case the 80%, you subtract the mean, and you divide by the standard deviation. This is going to become a very, very important formula. It's a formula.
There's no pluses.
Okay, and this is called a Z-score. Once we have a Z-score, then we can look up a chart in the back of our book. If you have the electronic book, it's on page 606. And it's going to give us a specific percentage. So when the percentage isn't exact, when these purple lines don't land exactly on a black line, then we can't use the 68, 95, 99.7% rule. We have to come up with, well, this is slightly, I don't know, is this 80%, is this 90%? I'm not sure. Well, this chart on page 606 is going to tell us. So if you kind of skim back in your book to 606, for those of you that took one the last day, it looks like this. Okay, I'm going to link an electronic version of this type of chart onto the D2L. I haven't done it yet. And you'll be able to just print that off and keep it with you always, and you can look up all your Z-scores. This gives us all the percentages. Okay, so this was the scenario. I'm not going to actually fully analyze this one because I have some other examples in mind. But the main goal is we need to understand that we are taking an X distribution of random data that we have about marks, about the length of fish, about cosmetic powder, about all those weird things that we did questions about yesterday, and fitting it to some standard distribution that always goes between -3 and +3, always has a mean of 0, standard deviation of 1, and is the beacon of telling us what all the percentages are for any value that you might land on. Okay, it doesn't have to be right on one of those standard deviation lines, and that's the key. Okay, when I do an example, it's going to become more clear what we're doing. And the idea here is, to be honest, the next 3 lessons are all based on this fact. There's nothing, we do a couple little renditions of it where you have to do a little bit more work or a little bit of different work, but everything's going to be based on this z-score, the z-score table, and converting x's to z values. Okay, so it's a short unit, but it also happens to be basically one topic. So we do have a quiz coming up this Friday, multiple choice, and then next week we'll have a little assignment on it. Okay, so if we go on to what would have been example 1 in here, this is the cosmetic powder question. Basically they say this, the mean is 50.5 grams. This is the same question we did last week. The standard deviation, so on average there's 50.5 grams of cosmetic powder in a pack with a standard deviation of 0.6 grams. Manufacturers want to ensure that each package contains at least 49.5 grams. You have to understand at least, at most. There's a whole bunch of wording that needs to be. What percentage do not? Okay, manufacturers want to ensure there's at least 49.5 grams. They want to say how many do not have 49. So we're trying to look up the probability that it's less than 49.5. If it's, we want to find out what percentage of the cosmetic powders have less than 49.5 grams. So the first stage to any of these questions is sort of, we're going to take each of our distributions and eventually we're going to match it to what we call a Z distribution, right? So every single time we're going to try to match it to this standard normal distribution. Okay, so I'm going to draw that over here so we kind of know what's going on. We're taking our X distribution and we want to convert it to a Z distribution. Well, what does our specific X distribution look like? Every single time you draw the mound, you're going to put the mean right in the middle, 50.5. And then you're going to add 3 standard deviations and subtract. 1, 2, 3. 1, 2, 3. So I need to add 0.6 3 times. So I get, should have made this a little bit, 51.1, 51.7, 52.3. Okay, this is all written on your, you should have printed this note like this. It looks very similar. Go the other way and subtract 0.6, 49.9, 49.3, 48.7. Okay. The question they are asking is very specific. What percentage is less than 49.5? So I have to find where's 49.5 on this graph. Well, here's 49.9, here's 49.3. It's somewhere in between. 49.5 is right here. Notice it doesn't land on one of the standard deviation lines. So I'm trying to find what percentage is under here. Well, you'll remember last week we would have added 0.15 times 2.35 times plus, I don't know, a little bit more. Was it maybe 6-7%? Something like that. We need to know. So you're saying, okay, well, how does this compare to this? Well, you have to do what's called calculating a z-score. We take our x value, which is the one they're asking us for, we subtract the mean, we divide by the standard deviation. So in our case, we take 49.5, we subtract our mean, which is 50.5, and we divide by 0.6. When I do this, I will get a value that you must, Morgan, can you be quiet for a second? You must list to 2 decimal places every single time. You'll see why in a second. So I get negative 1.66666. I'm going to put that to 2 decimal places, so I have to round to negative 1.67. Now, this is now a Z value. Z value of negative 1.67. So if I look at this chart and I say, well, where's negative 1.67 on here? Obviously between negative 1 and negative 2, it's right here. Well, what do you notice about these areas? This area is exactly equivalent to this area. Because what we've done is we've taken this random variable x about our ridiculous scenario, something called cosmetic power, and we've mapped it to the standard normal distribution. Once we map it to the standard normal distribution, it's like we've taken our x value and said, I want to find the percentage that's less than 49.5. Well, guess what? That's exactly the same as the percentage of z that is less than negative 1.67. And all you need to do is look this number up in the back of the book. So in the back of the book, the way this chart works, and it might be kind of difficult to see obviously, is all these values, there's a vertical column and a horizontal column. So you have to go find your value. So all the negatives are on this side of the page, all the positives are on this side. So I need to go to negative 1.6 on this side, negative 1.6. And because I'm doing negative 1.67, I look for 0.07 over here. So negative 1.67, I follow the row and the column, and it pops out a percentage. So in this case, it's 0.0475. That's from the back of the book. What that tells me is, if I multiply that by 100%, this is a percentage in decimal form, 4.75% of all powder is less than 49.5 grams. That's what it's telling me. This percentage that you look up, which is in this version of the Z-score table, it's always less than. Okay? So it tells us it's less than that. You look it up in the table, and it gives you a percentage. Okay? So here, remember I said, 0.15 plus 2.35 plus a little more, maybe it's 6 or 7%. Well, I estimated it's actually closer to 5%. Okay? But it allows us to take random variable x, some ridiculous scenario, and map it to a Z-score. And this is the method you're going to use every single time for the next 2 weeks. You are going to get very used to using this formula to come up with a Z-score, converting your x to a z, and then looking it up in the chart. Okay, the chart then gives you a percentage. If you multiply it by 100, it'll be a perfect percentage. Okay, do a couple more examples. Everything will make lots of sense. Okay, so example 2 comes in 3 parts, which is really nice actually. Because it's going to say, what if it's not less than? The chart only gives us less than. What do we do in that scenario? Morgan, what are you doing? Can I drag you over to show them what you're doing? Here. Go all the way in. This way. Go all the way in. Show me. You can fit yourself in a little square.
I think so.
Let's see. Talent. Okay, move back out. Okay.
I can fit it in. I can fit in here differently too.
Oh, great.
I'm flexible.
I wonder what it's like at everyone's houses. Parents trying to work all over the place.
And I'm doing gymnastics.
You're doing gymnastics beside me. Okay. Who knows what Ben's doing? We're not watching him. I think he's watching his iPad. Good parenting. Okay, so example 2, length of fish. Freshwater fish have a mean length of 20 centimeters. So most of these examples, you're simply, the information you need to know is what is the mean and what is the standard deviation. So in this case, 20 centimeters is the mean and a standard deviation of 5 centimeters. Find the probability that the fish population is less than 22 in A. So we're looking at different things. Probability that X is less than or equal to 22 centimeters. That's the first one. In B, we're going to see that it is greater than 16 centimeters. And in C, we want to see that it is between
Show them this.
10, Morgan, and
Do
30
it.
centimeters.
Do it.
Okay. There she is. Upside down. Okay, get out. So we want to look up all these things. And again, every single time you're going to be forced to do a Z calculation. And it might be beneficial for you to kind of draw a graph of what's going on. So if I drew a little graph up here and I said, okay, the mean is 20, and then the standard deviation is 5, that gives me 25, 30, 35. If I subtract, remember you're doing it 3 standard deviations on either side. Yes, Morgan? For now you can. Why are you bringing it in your room though? It stays over here. Okay, just go for now. Okay, so you're taking this is your X distribution, and you want to convert it to a Z distribution. So again, remember the Z distribution always looks the same. You start with 0 here, 1, 2, 3, -1, -2, -3. No Z value that you calculate can be outside of -3 to 3. If it's over 3, it means 100% is below it. If it's under -3, it must be 0%. So, I'm filming. I'm filming. Okay, I'll be in 2 seconds. My husband's home for lunch. Saga continues. Okay, so when you're going from an X value to a Z value, then you have to do the Z calculation, and that's what's going on. So sometimes it's easy. If it's less than that you're looking for, simply convert it to a Z value less than or something. You just have to find out what is this Z value. Okay, so in order to find the Z value, maybe somewhere on the side you go X minus X bar divided by sigma. In this case, your X is always the one you're looking for. Your mean is up here, and your standard deviation is there. So you're looking here 2/5, which is 0.4. So you want to find a Z value less than or equal to 0.4. Really 0.40. Remember I said 2 decimal places. So this, you look up in the back of the book, I look for 0.4, this is now a positive. Well, I go up to 0.4, I don't need to go to a second decimal place, so I just go to the first column, which is 0.4 and a 0, and I get 0.6554. Okay, 0.6554, that means 65.54% are less than 22 centimeters. Okay, that's that whole idea. Now, if you want to find the percentage that's greater, the whole idea is going to change, because here we're saying, okay, here's 16. I want to find out what percentage of fish are greater than 16 centimeters. Okay, well, the chart tells us how many are less than. Well, what percentage of the data is under the normal distribution? 100%. So if the chart tells you how much is less than and you want to find out how much is greater than, you simply subtract from 100%. So if it's asking you greater than, you're going to use this. 1 minus the probability that it's less than. The only thing you can look up in the chart is less than. Your only option. So you leave this 100% here, and this you'll have to convert. Sorry, I don't want to put that line there yet. This you have to convert to a Z score. And then you look up the percentage in the back of the book and get your answer. So your only step here is, if you see greater than, you have to convert it to a less than. Again, you have to find the Z score. Okay, obviously your X is different this time. You can't use the same Z score as here, because here X was 22. Here X is 16. 16 minus, the mean stays the same, 20, divided by 5, and you get negative 0.80. So I look up negative 0.80, negative 0.8, in the 0 column, 0.2119. Okay, so I don't know if you can see this, but you look up negative 0.8, because it doesn't have a second decimal place, you just go to the first column, which is 0.00, 0.2119, basically 21%. When I subtract it from 1, I get 0.7881. So in this case, 78.81% are greater than 16 centimeters of the fish, which makes sense, right? That's a huge portion here. Okay, the last section wants us to know what percentage are in between. Okay, how many are in between 10 and 30? We're looking at kind of this whole section here. How many are in between 10 and 30? Right there. Okay, well, the trick with this one, to go in between two values, is you want to find out the percentage that is less than your larger number all the way across here. So the probability that it's less than 30. But then when you do the probability is less than 30, you cover this whole area and you cover this area. Well, I'm not interested in this area, so I have to subtract out that area. I'm going to subtract out the probability that X is less than 10. That'll give me the stuff that's in between. And every time you do in between, you do the probability is less than your larger number and subtract out the probability it's less than your smaller number. What this makes us have to do is come up with two different Z values and then look up two different numbers in the chart. Okay, so you're really coming up with two different Z values. In the first one, you're doing 30 minus your mean, which is 20 over 5, and you get a z value of 2. In the second one, you go the other way. Z2, I'm calling it, is 10 minus 20 over 5, and you get negative 2. So I have to look up both positive 2.0 and negative 2.0. So positive 2 has a value of 0.9772. Negative 2 has a value of 0.0228. And when you subtract them, you get 0.94544. Okay, so that means 95% of the fish are between 10 and 30 centimeters. Okay, it's a little bit of a new process, but the idea here, maybe if you watch 4.4, I'm going to continue to do more examples like this. It'll become clearer before you attempt the homework. There is homework listed on this page, 430, number 1 to 10, 12, and 13. You'll get lots of practice. The practice is coming up with the z-score, looking up in the back of the book. If it's less than, it's a straight lookup. If it's greater than, you have to do 1 minus the lookup. If it's between, you have to do 2 lookups and subtract them. Okay, so I'll review this concept a little bit more in 4.4, and we'll go from there. Clearly it's lunchtime here. The masses need me. Multitasking all day long. Okay, thank you.